Right, so this is the pink notes. So I'm gonna go over two functions today, and it's not gonna take me that long. First is the cubic. So that means I'm gonna give you a table of values here on this margin, okay, for the cube. So this is x values, this is y values, and I'm going to use negative 2, negative 1, 0, 1, and positive 2. Okay, so what we're doing here is we're taking the cube of all these x values. Okay, so take the cube of all of them. So for example, the cube of negative 2 is negative 2 times negative 2 times negative 2. That is equal to negative 8. When x is negative 1, negative 1 cubed is the same as negative 1. And 0 cubed is still 0. And 1 cubed is 1. And 2 cubed is 8. Okay. So once you have the table done, then notice that this function, if I go left 2 from the origin, okay, left 1, 2, I have to go down 8. 1, 2, 3, 4, 5, 6, 7, and 8. So there's the first point. If I go left 1 from the origin, I go down 1. Okay, so this is the next point, and this is the origin. This is where the graph, it passes through the origin. And then if I go right 1 from the origin, I have to go up 1. So I get this point. And if I go right 2, up 8. So 1, 2, up 1, 2, 3, 4, 5, 6, 7, and 8. So then we connect the points. This is what that graph looks like. Okay, so this is the cubic function, and this is the graph of it. When you look at the graph, you can actually state domain and range. By looking at the graph, you're seeing this for the first time. So domain in set notation is x such that x is all the real numbers. In interval notation, negative infinity, positive infinity, because as you can see, this continues going to the left, continues going to the right. So that is the domain. The range is no different, continues going down and continues going up, so it goes to negative infinity. So y such that y is all real numbers, and in interval notation, negative infinity, because it's going to continue going down, and positive infinity because it's going to keep going up. Okay. All right. X-intercept, x and y-intercept, as it's at the origin, so it's the point 0, 0, and the same goes for the y-intercept. Okay. And then asymptotes. This one has none. There are no asymptotes on the cubic function. So the next one I'm going to do is the inverse of the cubic. Okay, so if I want to do the table of the inverse of the cubic, all I have to do is look at this table, and you just took a test over this yesterday. To do inverses, you just switch the x and the y values, so that's what I'm going to do here. So x is negative 8, negative 1, 0, 1, and positive 8. So now we're taking a cube, so that means we get these x values, but now they become the y values. So negative 2, negative 1, 0, 1, and 2. Okay, so with that said, let's plot the points. So if I go left 8 from the origin, I go down 2. 1, 2, 3, 4, 5, 6, 7, 8, down 2. That's the first point. And then if I go left 1 from the origin, down 1. And then the point 0, 0, that's right at the origin. And if I go right 1, up 1, based on this. And if I go right 8, I go up 2. So notice the difference between these two graphs. And like I said, these two functions are inverses of each other. So as you saw yesterday on the test, when you do domain and range of the function of f(x) and you do the inverse, you just switch them. But in this case, it's going to be the same thing. Okay. So then the domain is x such that x is all the real numbers. And then in interval notation from negative infinity to positive infinity. The range is no different. It's going to continue going down, continue going up. So then this is y such that y is all the real numbers, or negative infinity and positive infinity, depending on how the problem is asking you to do domain and range. If it says set notation, then this is what you use. If it says interval, then we use that for domain and range. X-intercept again, and y-intercept, it's the same point. It passes through the origin, so 0, 0 for the x-intercept, and no different for the y-intercept. Okay, asymptotes. This one has none. So notice that after this lesson, we only have 1, 2, 3 more functions, and then we'll be done. Okay. So with that said, I'm going to switch back to the notes packet. let's see. I had a copy of it here. Okay, so this is the new units packet. This is unit 14. So today you'll learn how to transform the cubic and the cube root functions, which again, this is the cubic and this is the cube. Okay, just to help you remember, I'm going to copy the table for the parent function. So this is y equals x cubed. Okay, so the table that I gave you on the pink paper, this is for those of you that don't have a copy of that pink paper. We said x is negative 2, negative 1, 0, 1, and 2. You take the cube, then this becomes negative 8, negative 1, 0, 1, and positive 8. But notice that this is being transformed. Okay, so the graph is going to be just like this one, but it won't be going from the origin because based on what's inside of the parentheses, there's a plus. So the plus means that you're going to transform the function by taking it to the left 5 units, and then that minus 2 is going to make the graph go down 2 units. Okay, so those are the transformations being applied. So from the origin, go left 1, 2, 3, 4, 5, and then down 1, 2. And there, this is where we're starting from, yeah. So then we go from this point. From this point, if I go left 2, I'm going down 8. So left 1, 2, down 1, 2, 3, 4, 5, 6, 7, and 8. If I go left 1, down 1, and this is the origin, so then if I go right 1, up 1, if I go right 2, up 2, 4, 6, I'm going by 2s, right? So this is 2, 2, 3, 4, 5, 6, 7, and 8. Then connect the points, and you'll see the same graph as the parent function. Okay, because it's just being translated to the left 5 units and down 2 units. So that's the graph of this function. So then let's go on to the next example. First, let's note the transformations. There's a negative in front of the parentheses. So that negative is going to make the graph reflect. So it's going to reflect over the x-axis. Okay, whenever you see a negative, that's what happens in front of the parentheses. Then that 1/2 is going to create a vertical shrink. So vertical shrink by a factor of 1/2. And then that minus 4 will make the graph go to the right 4 units. So these are the transformations to the parent function, which is y equals x cubed. Okay, so what I need to do is I need to copy this table just so that you can see it. I'm going to copy it again. So I'm going to copy that table. But then I have to do something to the y values. So negative 2, negative 1, 0, 1, 2, negative 8, negative 1, 0, 1, and positive 8. Now take into account this 1/2, and it's negative, so that means we multiply each one of the y values by a negative 1/2. Okay, negative 1/2 times negative 8, that's positive 4. Negative 1/2 times negative 1, that's positive 1/2. Negative 1/2 times 0, 0. This changes to negative 1/2, and 8 changes to negative 4. So then I'm going to go back and cross out this column because I won't be using that column. Okay, so we go right 4 from the origin. So this is 1, 2, 3, 4. So this is where the graph begins. That's the origin of the graph. From this point, if I go left 2, I'm going up 4. So left 1, 2, up 1, 2, 3, 4. If I go left 1, up 1/2, so barely noticeable. If I go right 1, down 1/2, and if I go right 2, then I go down 4. So this is 1, 2, 3, and 4. Then connect the points. And this is what this graph looks like. Okay, so let's go into the last example for cubics. So notice that there is a negative inside of the parentheses. That's a horizontal transformation. So the outside one affects the y values by creating a reflection over the x-axis. If it's inside, it's going to reflect over the y-axis. Okay, so I'm going to address that first. So this will be reflected, or it's going to reflect over the y-axis. And then that minus 2 is going to take the origin of the graph down 2 units. Okay, so those are the transformations. Again, I'm going to copy the table of the parent function. Then I need to change the x values and not the y values. So this is, let's see, this is x and this is y. Okay, so when x is negative 2, negative 1, 0, 1, and positive 2, negative 8 for y, negative 8, negative 1, 0, 1, and positive 8. Now, that negative changes the sign of the y of the x values. Okay, so what I'm gonna do in this column to the left, I'm gonna change the sign of the x value. So this changes to positive 2, this changes to positive 1, this stays to 0, and this changes to negative 1, and the 2 becomes a negative 2. Okay, because of that negative inside of the parentheses. So then I'm crossing out this column. So then I'm going to move the graph down 2 units. So from here down 1, 2. So this is where we go from now. So if I go right 2, 1, 2, I need to go down 8, right? So that's what this is saying. So right 2 down 8, 1, 2, 3, 4, 5, 6, 7, and 8. So that's that point right there. If I go right 1, down 1, and if I go left 1, up 1, if I go left 1, 2, up 1, 2, 3, 4, 5, 6, 7, and 8. Then I'm going to connect the points. And this is what that graph looks like along with the transformations to the parent function. This concludes 3 examples on the cubic. Now let me give you 3 examples on the cube root, about the cube root. So for the cube root, the parent of the cube roots is this one here. So y equals cube root of x. I'm writing the next here should be at 3. Okay, so this is the cube root of x. All you have to do is take the table from the parent function of the cube and switch the x and the y values. So I'm going to copy that table, but I'm going to switch them. So when x is negative 8, negative 1, 0, 1, and positive 8. So the cube root of negative 8 is negative 2. Cube root of negative 1 is negative 1. Cube root of 0 is 0. Cube root of 1 is 1. And cube root of 8 is 2. I'm sorry. Okay, so now let's talk about the transformations to this graph. So first, there's a 3 in front of the radical. So that 3 is going to create a vertical stretch by a scale factor of 3 units. Okay, vertical stretch by 3. That plus 2 inside of the radical, it's counterintuitive. It's going to go to the left 2 because you might think this goes right. No, it goes left 2. Then the minus 4 is going to make the graph go down 4 units. And once I have the transformations, I'm going to follow what I said here. It's going to go to the left 2 from the origin. So this is 1, 2, and then down 1, 2, 3, 4. And this is that graph. Okay. So what I need to do is, and I didn't give myself a space here. What I need to do is take the y values and multiply them by 3. So if I multiply this negative 2 times 3, that gives me negative 6. So if I go left 8, I'm going down 6. So left 1, 2, 3, 4, 5, 6, 7, 8 down 1, 2, 3, 4, 5, and 6. So if I go from this point, if I go left 1, I'm supposed to go down 1, but then multiply that by 3, so go down 3 instead of 1. So left 1, down 1, 2, and 3. The same thing happens to the right. If I go right 1, up 1, multiply that 1 by 3, so up 1, 2, and 3. And the last point, if I go right 8, I'm supposed to go up 2, multiply that 2 by 3, then it's 6. So I'm going to go right 1, 2, 3, 4, 5, 6, 7, 8, and then up 1, 2, 3, 4, 5, and 6. So then I'm going to connect these points, and then you'll be able to see the vertical stretch on this graph in comparison to the parent. Okay, so this is what the graph looks like. All right, so then let's go down to the next example. Again, notice that there is a negative in front of the radical. Okay, so I'm going to copy the table, of the parent. So this is x and y, and I have enough space here to be able to do the transformations on the table. So the same table as this one here, I'm just going to copy it. So -8, -1, 0, 1, and +8. This is -2 for y, -1, 0, 1, and 2. Now, there's a -1/2 in front of the parentheses, so let's multiply each one of the y values by -1/2. So -1/2 times the y values. So all we have to do is change the sign and take half of it. So 1/2 of 2 is 1. Negative times negative is positive. 1/2 of -1 is positive 1/2. 1/2 of 0, that's still 0. Or 1/2 times 0. -1/2 times 1, this now becomes -1/2. -1/2 times 2, now it's -1. So then I'm going to cross out the center column because I will not be using those values for direction. Okay, so let's state the transformations. First, the negative. The negative makes the graph reflect over the x-axis. And then the 1/2 creates a vertical shrink. So vertical shrink by 1/2. And then the last transformation is to the right one because of that -1 side of the radical. So right 1 unit. Okay, so let's go to the right one. So we start from this point and then let's apply this table. So if I go left, 1, 2, 3, 4, 5, 6, 7. Let me count again. So 1, 2, 3, 4, 5, 6, 7, 8, down, up 1. So up 1. If I go left 1, I have to go up 1/2. So that's this point here. And then if I go right 1, down 1/2. So this is barely noticeable. And if I go right 1, 2, 3, 4, 5, 6, 7, 8, I need to go down 1 unit. Okay. So then I'm going to connect these points. So this is barely noticeable for this function. One last example for the cube root. Notice there's a negative inside of the radical, so that affects the x values. So let's do the parent function table. So then we use the parent function table, and since we have a negative inside of the cube root, then we change the sign of the x values. Okay, so then this becomes +8, this becomes +1, this remains 0, this changes to -1, and this changes to -8. Then I'm going to cross out that column. Okay, so there is only one transformation, and that is that the graph gets reflected over, not the x-axis, now it's the y-axis, over the y-axis. Okay, that's the only transformation. So then there's no horizontal or vertical translation. So then we go from this point. That's the origin. From here, if I go right 8 units, I go down 2. So 1, 2, 3, 4, 5, 6, 7, 8, down 1 and 2. If I go right 1, down 1. If I go left 1, up 1. And if I go left 8, so this is 1, 2, 3, 4, 5, 6, 7, 8, up 1 and 2. So there I have the points based on this table. Then connect the points. And this is that graph being transformed. So notice that this graph, okay, this graph here, this graph and that graph, this has a reflection over the x-axis and this has a reflection over the y-axis, but there is no difference. They look the same. Okay, the same thing happens here. This is a reflection over the x-axis, and this one is a reflection over the y-axis. So notice again, there is no difference. It looks the same. So I'm going to add a note here, and that note says, I'm going to say notice. Okay, so notice the following. Vertical reflection or reflections and horizontal reflections do the same thing. So you can't really tell the difference with the graph. So they do the same thing.